Yeah, so hello everyone, I'm Haraken. So nice to meet you and welcome everyone to the BlinkOn, lightning talk session. So are you excited? Great. So however, I got one problem. So as usual, I wanted to kick off this lightning talk session with a party popper. So however, party poppers are not permitted in the airplane, right? So however, after arriving in this Bay Area, I was walking around in a supermarket and I actually found a party popper there. Amazing. Okay, so let's celebrate. So let's kick off the lightning talks. Okay? 1, 2, 3, blink on. Okay, so I needed to clean up, but let's do that later. Okay, so today, we will have 11 lightning talks, and each talk is 3 minutes long. So if you are a speaker, please come to the front and stand in line, and make sure to finish your amazing presentation in 3 minutes. So 3 minutes is the hard limit. So is that okay? Okay, so let's get started. So the first speaker is Yose.
Okay, this is Jose Apena from Igalia. Today I'm going to talk about the container timing specification. Okay, so first we have element timing. It allows to obtain rendering timestamp information from a specific HTML element. We support images and text elements. And yeah, we can use the performance server to get that information. But there's a problem. The main problem we have is that we need to add the element timing attribute element by element we are interested in. So there's no way to aggregate information unless you do it manually. What about LCP? LCP is page-wide, so it's way too much. We need something in the middle. So what can we do? We have the container timing API that we are proposing. It's a variation on element timing. It monitors an HTML element and all these descendants. So the idea is, again, the same thing, getting the information about when rendering is happening and also about the area that is being rendered. Okay, this is how the event looks like, where we have the intersectional rect to see more or less the area that has been painted. We have the start time and the first rendering time, so you can get a kind of time range of when things are painted. Well, this is how it looks like for using it. We put the attribute container timing on the element we're interested in, and we can use the performance server to register for a container type of event. Okay, discussion is in progress right now in the web perf working group. We have an explainer that has a polyfill, some examples, and a Chrome extension for playing with the feature. We are experimenting with a couple of things. One is being able to ignore part of the tree that we're registering on using the container timing ignore attribute. And another one is basically having an ST policy to know what happens when you have top level container timing root and then another one inside. Okay, so I wrote an experimental native implementation in Chromium, and yeah, the basic implementation has landed. Yeah. So you want to try it? You need to enable the feature flag container timing, and yeah, more experimental features and attributes will follow after that. So if you are interested, read the explainer, play with the implementation, and yeah, provide feedback. This work has been sponsored by Bloomberg, and thanks.
Yeah, so thank you very much. So the next speaker is Jeffrey.
Thank you. I'm Jeffrey Eskin. I co-tech lead web standards for Chrome, and I'm on the W3C tag. And I will be talking today about the emergent architecture of the web. So the tag 20 years ago wrote a document about web architecture, which talked about URIs, HTTP, the division between HTML, CSS, and JavaScript. This is the designed architecture of the web, the decisions that people explicitly make. Over the over the lifetime of the web, these evolved into some higher level architecture that kind of emerged. And if we want to guide the web in good directions, as the tag is tasked to do, we have to understand what that architecture is so that we can decide what changes to make. So what goes into the emergent architecture? Well, users have to access the web. We often think of that as going through browsers, but it also goes through in-app browsers in apps, and recently goes through AI chatbots. So we have to think about all of those ways when designing changes. People have to discover websites to visit. A lot of times that goes through search engines nowadays, but people also keep bookmarks. They find URLs in the real world, and they follow links between websites. So we should think about how to keep people discovering good websites. Websites have to get written somehow. This ranges from digital sharecropping on the Facebook, YouTube, TikTok end to running your own web server and writing complex programs that generate the pages people see. People write websites for all sorts of reasons. And we have to make sure that the good websites that we have, their authors keep getting the things that motivated them to create the websites. All of these authors have to eat, and so money is involved in getting a lot of websites made, and a whole lot of that is advertising. So we have to pay attention to how advertising interacts with the whole web. And finally, we need to look at how websites and the web are governed. We all know and love the standards bodies, but there's also national regulators from every country in the world. And we have to look at how all of that interacts. It's a tag project this year to figure out the architecture of the web, document it, and then start trying to figure out how to tweak things and push things in good directions. So talk to me if you have good ideas for how this should go. Thanks.
Yeah, so thank you very much. The next speaker is Sharon.
Thank you. Hello, everyone. I'm Sharon. I'm from the Chrome Security Architecture team. You might recognize me from the popular internet series, What's Up With That, where I talk to people who work on Chrome. If not, check it out. But we're not talking about either of those today. Have you ever had a crash you just can't figure out? Okay, good. Not just me. When you debug, do you log error and hope for the best? All right, well, you can leave those painful debugging days behind you. Now introducing Pernosco, your new favorite debugging tool. Yeah, I didn't know about the popper thing. Anyway. Yeah, so simply take an RR trace of whatever's giving you grief, upload it, and you get all of this. Wow. So here we have our code. The orange squares tell you which lines have been executed, and the green highlighted line tells you exactly which line we're at. So no need for the GDB frame command anymore. But GDB's got lots of other features. If you want to use those, down here in the GDB panel, print stuff, evaluate stuff. And we have the power of RR, so you can go forwards and backwards, which is cool. Up here, we have our std out panel. Straightforward, shows you what's been written to the console, including reminders of your earlier debugging attempts. And here we have a stack panel, which shows you the stack of the highlighted line in green over here. As you move that green line around, either by clicking or by the GDB panel or other ways, this will update accordingly. So cool, so many features. But wait, there's more. So you can search up any function by name. It'll pop up down here. We have two examples. You can see that parameter values are also printed, very handy. And if you drop one on top of the other, they interleave. Wow. I thought that was really cool. Maybe just me. But you might see this thinner green line here. That also corresponds with that green line there. So super handy if you call the same function a lot of times. So try it out. Try Pernosco now. After trying it, you might find yourself solving difficult debugging problems, enjoying it, continuing to use it, maybe even giving a talk about it. Only available on physical Linux workstations, cloud top support coming soon, does not work with source internal, and you do need an RR trace of the thing you're having a problem with. But start now. If you start in the next 2 days, there's a workshop happening over in San Francisco Thursday afternoon, given by Stefan over there. Raise your hand. All right, talk to either him or myself for more details. Thank you very much.
Thank you very much. So the next speaker is Martin.
Hello, I'm Martin. On the Chrome Privacy Sandbox team, and I'm here to talk to you about a new kind of sub-resource filter. So one of the things that Privacy Sandbox is thinking about is how to protect users against the misuse of web APIs to re-identify them across sites. One of the proposed interventions is to identify site resources that collect this type of information in a third-party context and block them potentially from loading or executing. We are not the first people to think about this. In particular, the sub-resource filter. There's a component that was built to block ads violating better ad standards. Already exists, and under the hood it uses the URL pattern index for matching URL patterns. That also underlies our implementation of the declarative net request API. This is just a very simplified diagram, but you get new versions of a rule set from a component updater. And then there's a rule set service that indexes them for efficient querying. And then on the browser, there's a throttle manager that sort of decides whether we're going to check the rule set for requests on the page. And it coordinates between navigation throttles that handle like pausing requests and deciding when to block. And there's also render agents on each render process that handle sub-resource filtering. So this kind of infrastructure already existed, and it was very suited to our use case. So in partnership with the sub-resource filter owners, what we've done is we refactored the sub-resource filter codebase to support multiple filters. We implemented a new one with similar architecture but different activation conditions. And we also have been working via a custom crawler, generating a list of URL filtering patterns that we suspect of API misuse and infrastructure to keep it updated. And this is currently in testing as a Google internal bench experiment. But yeah, keep a lookout for more news to come. There's an experiment flag if you are interested in trying it that I linked on these slides. Thanks.
Thank you very much. And the next speaker is Fagar.
Thanks. Hi, I'm Fergal. I work in Tokyo on the storage team. I'm going to talk to you about deprecating the unload event. So the unload event is the last thing that runs in the browser when you navigate away from a page. It's the thing that turns off the lights on the way out if you want to. So yeah, it's the last event in the page's lifecycle. It's unreliable on mobile because often we kill a browser or kill a page, kill a process without running any of those kinds of events. It's reliable on Chrome desktop, but we introduced something called the BF cache, and BF cache it's not the big friendly cache. It's the back forward cache. When you navigate away from a page, right, we don't destroy all of the stuff. We keep it around. We just pause it. When you come back, we unhide it. It's a big win for page load speed, but it's not compatible with the unload event. If you have unload events on your page, we have to make a choice between doing things correctly or getting the speed win of BF cache. So. Ooh, I missed something there. So let's see. So yeah, unload blocks it, BF cache on 12% of history navigations on desktop. So that's it's like the second biggest remaining blocker of BF cache usage. On mobile, it's already unreliable. So we made the decision that prioritizing BF cache over running unload events is the right decision. It's making it less reliable, but if you were relying on unload on mobile, you were already going to have a bad time. Your user were already going to have a bad time. So that's what we did, and that's what all of the other browsers did too. This is the SPECT behavior to prioritize BF cache over unload. What we do on desktop, well, it's reliable on Chrome desktop, and that's a problem, right? Enterprise apps rely on it. We know that if we disable unload, a bunch of enterprise apps have problems, and so but we still want everyone to stop relying on it. So we have a kind of a dilemma here. The approach we're taking is to give people control. So we introduced a permissions policy, a new feature called unload. It's enabled by default. So unload, you don't notice. If you don't do anything, you don't notice anything. But you can disable unload for your whole site by setting the header to disable it. So that means if some random dev on your team tries to make your site depend on unload, they will fail, and your site will continue to be BF cached successfully, and whatever it was they were working on won't work that way. So, for example, Google Search does this. It's one of the first adopters last year or the year before. But we can't expect everyone to adopt this thing. It's a permission policy. These things just don't get adopted, basically, even if they're good for you. So we have a deprecation plan. We're going to gradually change the default from enabled to disabled. We're starting with the top 50 sites. Currently, we are at the top 1, which is google.com. Yeah. Yeah, we're at 1% of 1 at the moment. It's rolling out at the moment. Later on, we will, after we've done the top 50 and hopefully haven't had complaints and disasters and whatever, we will start to switch the default for the world in general. It'll take about a year, probably take more. Honestly, it probably won't go that smoothly. Yeah, that's just changing the default for permissions policy on load. We're not actually turning it off. That will take much longer, and we're not touching WebView at all at the moment. So that's, oh yeah, if you think you need unload, do you really need unload? Switch to page hide and page show. If you were saving data in unload, you were already doing it wrong. Use visibility change. If you need to send like an end of page beacon, we have the new fetch later API, which came out of the BF Cache team for this purpose so that people could stop using unload. And if you really need to, you can opt out. There's a deprecation trial that switches your default back, and you can just set your permission policy explicitly. I think that's everything. Thank you.
Thank you very much. And the next speaker is Mohamed.
Hi, I'm Mohammed. I'm working Chrome in Munich. So today I'll be talking about cross-device digital credentials. This will not be more about digital credentials, but about the cross-device part of it. But for context, digital credentials, for those who don't know, are a digital form of your mobile driving license, for example, that you would need to present on the web to verify some information about you. So can we roll the video? So today, digital credentials only exist on digital mobile wallets that are only available on mobile devices today. The question is how we can present them on the web, on desktop, for example. So this is currently the flow. Like the user will, the website will invoke an API, Chrome desktop will present a QR code, you scan it with your phone, and then magic would happen. Both devices would communicate with each other and then exchange information that you would like to exchange. The same flow is used also for passkeys. So this is not specific to digital credentials. And this talks about how actually this is happening, what's happening under the hood. So I'm sorry.
That's all right.
Yeah, so what happens here? So, yeah. So on desktop, the website will invoke the API, and Chrome will realize, oh, that's an API that requests digital credentials, which only exist on the phone. So let's actually phone a friend, like literally, to get that information. So how to do that? Let's display QR code such that we inform the mobile device about what we need. There are many information in this QR code, but two are most interesting for us is the encryption public key. Like Chrome desktop will say, this is how we should communicate together to communicate securely. And also they would display a hint that we are requesting digital credentials. And this is how the phone would know what exactly is being requested. And then this moment on, Chrome will put on his headset, listening for Bluetooth incoming messages. Why is that? To make sure the device that would respond to this QR code actually is within the proximity of this, like the desktop Chrome or any other browser, not only Chrome. And the reason for that is you cannot just phish some user by sending a QR code over email and trick them into scanning that with their phone. What happens on the other side? Like the phone will scan the QR code. Oh, that's actually some user looking for presenting their digital credentials. So I know that Chrome now will probably be listening for Bluetooth message to confirm my proximity. So let's do that. I will tell them, hey, I'm an Android phone, for example, in this specific case. So I can communicate using Google servers. If this was an iPhone, it will say that, hey, I'm an iPhone device, can communicate using Apple servers. And I got your encryption key. So now Chrome desktop will actually got that message. Oh, okay, so someone on the other end is ready to listen through the Google servers. So I'll start communicating with that device using Google servers, using the encryption key that was exchanged in the beginning. And then they will start communicating like securely together this moment on. Thank you.
Thank you very much. And the next speaker is Christine.
Hi, everyone. I'm Christine Hollingsworth. I'm a software engineer on the Chrome Intelligence APIs team, and today I'm going to talk about translator and language detector APIs. Based on the name, you could probably figure out how these two APIs work. They have lots of benefits, such as driving efficiency and working well together. But there have been some challenges. These APIs are both in origin trial currently in Chrome, and we've received a lot of positive feedback from developers in terms of usability and result quality for both APIs. But for language detection particularly, single word queries yield unexpected results. Let's say you're a site that prioritizes your Spanish users, Spanish-speaking users. Let's say the user types in zapatos. Would you expect the results to be Bulgarian, Sudanese, English, Javanese, 11 more languages, and Spanish coming in at a whopping 0%? Probably not. We mostly explore this problem in Spanish as an example. It likely exists for other languages, but we haven't measured the impact. So you might be thinking, this sounds more like a model result quality problem. Like, what does that have to do with you? Model iterations and improvements take time. Is it possible to fix this as an API owner and a developer in the meantime? Let's find out. You can manually append the article to the word to try and improve result quality. You're familiar with the problem. You append the correct article. We got 28%, that's better than 0. But we discovered through testing that if you just always append L to a given singular Spanish word, it really, really works. 61%. All right, let's try it again in French. The same shoes example. French is at 44. We add the article, 93. We add this, without the S, 96%. All right, very interesting. It seems simple in theory. We did measure an improvement, but we're not sure why it works. It disobeys the laws of grammar. And it might not work so consistently for other languages. Plus, it's a chicken and egg problem, like what article do you append if you don't know what language you're detecting in the first place? We also considered using a fallback dictionary, but that's kind of defeating the purpose of an on-device AI API in the first place. We could also allow some developer input using the expected input languages parameter to weight results. But we'd have to also maintain this dictionary, store it, decide what words are going in it, and possibly remove it once model results improve over time. We've only begun to scratch the surface of this problem. So if you have any other ideas to improve single word language detection results, we'd love to hear them. Thank you.
Thank you very much. And the next speaker is Matt.
So hello everyone, I'm Matt. I work for Google for Private Sandbox. Well, no one actually mentioned AI like multiple times. I'm going to do this. Well, that's cool. So web compatibility is kind of hard to do. We're doing also some private metrics collection. You need to have a lot of data to do web compats. So we figured out, okay, let's try AI. Maybe it will help. So there are a few cases, right? We can look at the data and try to analyze that using AI. Or like, okay, let's start something simple, which is like we have a lot of bug reports, which they state that, okay, something is broken. You just have to go, like we have a lot of those cases for 3PCD, third-party cookie deprecation. So you have a pretty good amount of bugs that we want to track. So I was like, okay, let's just try it and make sure maybe some of those cool AIs will help us with retesting broken scenarios and do it automatically and fast. So what I start with a simple prompt for one of our cases. So I basically analyze the whole bug myself. I was like, okay, that's kind of the steps that I need to put to AI to make sure that they will retest it. And I used two things. One is like internal tool, and the second one is a ChatGPT operator. It will take over the whole Chrome experience and will do it for you fully, right? So I put the prompt there, and that's the result. It's pretty cool. So you say that I confirm that when the third-party cookies are disabled, accessing the logs logs you out from the Steam Power or something, right? So that's cool. But you have to make sure that you have one specific, for every single bug, you have to have one prompt, right? Which is not ideal. So I was like, okay, this works. Let's go. Let's go maybe wider and put some generic prompt, right? So I just created like a simple AI prompt first, like, hey, we'll be talking about third-party cookies, deprecation, all of this. Like, please try this bug. And I basically copy and pasted the screenshot of the bug report. So it worked, but as you see on the right-hand side of the slide, I had to message that a little bit, right? So it was a little bit picky about trying to disable cookies. It didn't know how. By the way, the other session on the previous session it did, so that was actually tricky. So, but again, at the end of the day, it looks a little bit promising to us, right? So we have hundreds of bugs that we need to track right now, and right now we are doing automatic retesting of all of this, so we could actually reduce the amount of effort that we have to put, and we could use AI to it, right? Like those operators or agentic AIs. So the thing is that you need to make sure that you have a full training for your type of work, right? So for example, for third-party cookies, you need to put a lot of context to the AI, so to actually know how to disable and enable cookies, etc., etc. So it's not scale, so it doesn't scale that easily to a different types of bugs, at least for now. But generally, super useful. So we are going to put more effort into this research, and let's see how it goes. Thank you.
Thank you very much. And the next speaker is James.
Thank you. Hi, everyone. I'm James Scott from Google, and today I'm here to speed run through some updates about web status.dev. As a quick reminder, web status.dev is a dashboard for understanding the web platform and its features across all major browsers, providing up-to-date information such as browser availability and web platform test scores. It also highlights things like baseline features, which indicate interoperability across browsers. And you can also track feature progress over time. And with all this information, web status.dev also offers powerful querying, giving users the ability to analyze web platform data specific to their needs. Now, onto the updates. First, we heard about the different state of X surveys earlier. So we look at the state of CSS and state of HTML surveys, and those are great community-run surveys that provide valuable data such as interoperability challenges faced by web developers. And utilizing the recent 2024 results, we've created global bookmarks that present the top ranked pain points from those surveys. And we supplement them with information that we collect that I mentioned in the previous slide. And we think that by supporting these efforts like this and adding the data that we collect, we're enabling browser vendors to prioritize appropriately. And on top of that, we've added even more bookmarks. We had some previous baseline bookmarks. Now we've added more years from 2020 to 2025 so that people can better understand the evolution of web platform and the interoperability story. Next, we've also added a way to better understand feature adoption. We've added Chrome usage metrics. So on the home page, you'll see the latest snapshot, and as well as if you dig down to the feature detail page, you'll see a historical view of the usage data as well. And together with our existing data, we hope that this will provide a more complete view so that you can make a more informed decisions about feature development. And then finally, to enable a more personalized experience on web status.dev, we're introducing a highly requested feature, user-saved searches. This is coming very soon, by the way. This allows you to create and save your own custom search queries and easily edit them as your focus evolves. And as well as your team can bookmark your searches, and they can also reference them in the future as well. And you can imagine the collaboration that this starts to enable as well going forward. And with that, I am done. Thank you. Feel free to reach out if you give me questions.
Thank you very much. And the next speaker is Rick.
Thank you very much. So an OMG is what we call a major incident at Google. Last BlinkOn, I gave a whole talk on incident response type stuff, but I had a really fun personal anecdote that I thought I would just share. Just a couple months ago, I was on vacation in the Cayman Islands, and my family wanted to book a Stingray experience thing, and I'm trying to furiously book this thing for 6 a.m. the next morning. And I go to purchase, and the form won't submit. It says, please select a state. And no, this isn't because it's Canada and we don't have states in Canada. It's just, even if I picked USA, I couldn't submit a state. And I was like, what the heck? And so then I tried Chrome Stable and it worked fine. And I thought, uh-oh. And I thought, I'm too busy. I don't want to think about this. I'm on vacation. But then I remembered the talk I gave and said, no, okay, I can take 5. It doesn't take long. I'll just very quickly reproduce it, write repro steps, file a bug, and then forget about it. It's not my problem anymore. And so sure enough, it took me 5 minutes. You capture your pinch state in a variations.txt file a bug with repro steps, and then I ignored it until I got back from vacation. And after vacation, I was pleasantly surprised to find that you notice the timestamps here. This is 6:48 p.m. on February 4th. By February 5th at 11:30 a.m., our test team had reproduced it and used Finch bisect to find out which Finch experiment was responsible for this regression. And by 1 p.m., Joey, thank you very much, Joey. Joey jumped on it in record time. I then realized that it was indeed a regression caused by his experiment. The site was doing something surprising, but something that has always worked in every other browser. And so Joey decided that the right thing to do in this case was to actually change the HTML spec to allow this crazy thing to happen and to avoid sending this to stable. And so this small business who was about to lose any ability to sell to any Chrome user never even noticed that anything went wrong. And that's just one small example of avoiding an OMG. But I think there's some common patterns here that if we all do, right, we should all care about the quality of the experience that we create. And I think it starts with dogfooding. Please use beta channel, dev channel, and be curious when something doesn't behave as you expect. You don't have to dive in and start debugging. All you need to do is say, stable is behaving better than beta. And you can file a bug in 2 minutes if you ever notice that. And you can trust, we've got whole systems in place. If you want to dig deeper, you can play with these scripts yourself, bisect variations or bisect builds, which can find what CL or what Finch experiment caused a regression. But if you just tag your bug as a regression, then generally this will happen for you automatically, like it did in my case. Also, this relies on you please triaging your bugs quickly. If somebody sends you a bug and says you have regressed beta, be aware that any pain in beta is probably 1% of the pain you will feel when that hits stable. So better to jump on it quickly. And it's not always the right thing to do, but in general, we should default to saying that if we have made a change that breaks the web, it's probably not the developer's fault. It's so easy to say, well, the web developer did the wrong thing. No, I'm sorry, you changed things. The default assumption should be we changed the specs. It's so much easier than changing the web. In other cases, we decide not to do that, but we got to be careful when we decide not to do that. And that's all. Thank you.
Thank you very much. And the final speaker is Dan Murphy. Dan Murphy. Okay. So in that case, so I think that's it for today. So thank you very much for the so many updates. So please send another round of applause to all the speakers. And also, I want to say a special thank you to Mike Taylor. So where is Mike Taylor? He's in the meeting. Okay. So yeah, so he contacted all the speakers and concatenated all the slides on time. So thank you very much, Mike Taylor. So yeah. All right, so that's it for today. And so tomorrow, so we will have 2 more lightning talk sessions. So thank you very much for coming. And so see you tomorrow. Thank you very much.